This is going to be the first recording of the CCNA 3 course, Chapter 2, Scaling VLANs. We're going to skip Chapter 1, which kind of just talks about the core distribution and access layers, a little bit of review of CCNA 2. So this is where actually newer material gets introduced. You'll see so there is some overlap between CCNA 2 and 3 in terms of concepts that we'll be discussing specifically in this chapter and a couple other chapters as well. I plan on trying to crank these videos out at least once a week. I really don't have a set incentive to keep going with them, but I'm going to try. I'm not teaching the class right now. I actually stopped teaching and I'm working as a network specialist for the county. So I am going to take my own CCNA exam soon, so in order to help myself prepare and help you guys out as well, I'm going to record these videos. So I'm going to try to keep at them, like I said, at least once a week. So that's how things should shake down for Chapter 2 here. We've got VTP, VLAN Trunking Protocol, Extended VLANs, Dynamic Trunking Protocol, DTP, which is something we've seen in CCNA 2, troubleshooting multiple VLANs, and Layer 3 switching. So that is what we will be hitting in this chapter. And we're going to start off with VTP. So VTP is going to be used to help network administrators manage their network more easily. If you have a lot of switches in your network and you're trying to set up VLANs on every switch, it's going to be quite time consuming. Through VLAN trunking protocol, you're going to be able to designate one switch as a server through VLAN trunking protocol, and it's going to be the switch you configure all your VLANs on, and basically that server is going to relay that information to all the switches that are set up as clients in that domain. So you only have to manage your VLANs on one switch instead of setting them up everywhere. So that information is shared from server to client, and clients will share them to other clients. So although the clients aren't used to set up the VLANs, the clients all do relay information that they learn which originated from the server. So eventually all the switches in that domain are going to have the same VLAN set, okay, again, which was configured on the server. A transparent switch in VTP is going to have its own VLANs. You set it up manually like you normally would. What it will do is it will share VLAN information. It will pass it on to other clients, but it's only going to pass on that information that those clients are sharing from the server. If you've configured VLANs on a transparent switch, it's not going to forward that information to other clients. So you don't have to worry about that interfering with the settings that you've configured on your server. Transparent is going to be its own self-contained thing. It doesn't forward out any of its VLANs, but it will forward VLAN information that is sent by other clients, okay, which of course originate at the server. So it all works pretty harmoniously. So originates at the server, clients share that information amongst themselves. Transparent will share it as well, but it does not use it itself. Everything on a transparent switch is configured on that switch and stays there. It does not get shared. Okay, so hopefully that is clear. So we talked about, or I mentioned the VTP domain. That's just the area in which you are sharing VLAN information. You see this description here, the description here consists of one or more interconnected switches, all switching in the domain share VLAN configuration details using VTP advertisements. We'll talk about those VTP advertisements in a second. So they're all going to end up with the same VLAN information. Switches that are in the different VTP domains do not exchange VTP messages. A layer 3 router defines a layer 3 switch or a router defines the boundary of each domain. Okay, breaking up those domains with, well, some type of layer 3 device, either a router or a layer 3 switch. Okay. Some other things, the server if your switch is configured as a server, it does store its VLAN information in NVRAM, so if it gets reset, it will remember that VLAN information. A client does not. It stores its VLAN information in RAM. So you're going to have a bit of a different situation there in that if a client gets reset, it forgets the VLANs. But if you bring the network back up and running, it'll have to go through a period of convergence, and eventually you'll get all that information from your server. So that's how it's going to work. All right. So that brings us to the advertisements down here. 3 types of advertisement: summary, advertisement requests, subset advertisements. Okay. Summary, those summary advertisements are sent out about every 5 minutes, or really every 5 minutes, pretty much on the dot. And that contains domain name and revision number of the VLAN data. Okay. So domain name is just the domain that all of your switches are in. The VLAN revision number, or the revision number period, is basically how up to date your VLAN information is. The lower the revision number, the more outdated your VLAN data is. Okay. I'll try to explain that a little further in a second. Advertisement requests is if your VLAN data is outdated, if your VLAN information is outdated, you're going to send that advertisement request, and a subset advertisement is how you will receive that VLAN information back. So here's how it's going to work. If we go here, we've got S1, S2. S1 sends a summary advertisement to S2. All right. That summary advertisement again has the domain, the VTP domain, and the revision number. If they're in the same domain, S2 looks at it. If they're not in the same domain, S2 is going to just discard it. Okay. Sees it's in the same domain, then looks at the revision number. If the revision number on the summary advertisement that S1 sent to S2 is lower than the revision number on S2, then S2 ignores it because it knows it's older. If that revision number that S1 sends is higher, S2 is going to say, okay, my information's outdated. I need to get that information back, or that update that S1 has for me. So in order to get that update, S2 is going to send this advertisement request, VTP advertisement request, to S1, asking for the change in the VLAN database. Then S1 is going to send back that subset advertisement that actually does contain the changed VLAN information. So that's what you're going to see there. So that's basically the whole exchange. Summary, checks it out. If it's outdated, requests an update, and then S1 sends that updated information to S2. That's how it's going to break down. Okay. We'll go on to the next one, I guess. I didn't even click anything, and it changed on its own. All right. All right, you can see here that VTP has 3 versions. The only ones we're concerned with are VTP versions 1 and 2, by definition, really. VTP 1 is the default VTP mode on all switches. It supports normal range VLANs only. VTP 2, version 2, supports normal range VLANs only, also supports legacy token networks, supports advanced features including unrecognized time length value, version-independent transparency mode, and consistency checks. Again, type 3 is beyond the scope of this course, so just know that by definition. We just talked about the revision number a little bit, and here it is down here, basically saying, well, what we just defined it as. The revision number is used to determine whether a switch should keep its existing VLAN or overwrite it with the VTP update sent by another switch. So the higher the revision number, of course, the newer the VLAN database. So that's kind of how it goes. When a switch is added to a network, ensure that it's in the default VTP configuration. Main reason being is because if you take a switch that was on a different network, add it to yours. Maybe it had a higher revision number than the other switches on your network already stored. Okay, and that's going to cause lots of problems, because if you set it up as a client, it's got a higher revision number and maybe has some data from another network on it, then you're going to get this other network's data being shared between all your clients because it has a higher revision number than your original network. Okay, so it can really mess things up for you. So that's why I say we want to put it in default VTP configuration. 2, if you need to reset a revision number, what you can do is change the domain that the switch is part of. If you switch to a different domain name, then switch right back to the original, it will clear out the revision number on that switch. So that's the way to reset the revision number. So VTP configuration, what you're going to do is configure the VTP server, configure the VTP domain name and password, clients, the VLANs on the server, verify the VTP clients have received the VLAN information, and how that's going to look. How's that going to look? Well, like this. You've got your VTP mode command. You can go VTP mode client, off, server, transparent. One of those two. Of course, if we saw that step 1 is configuring the VTP server, so we go VTP mode server. Step 2 was configure the VTP domain name and password, so we go VTP domain, whatever name you want. For this example, we went with CCNA. And the password is going to be VTP password, whatever you want it to be. Okay, you can verify that with a show VTP password. To configure the clients, you've just got VTP mode client. Same thing we saw on the first slide pretty much, or the first step I should say. And this is basic stuff we learned in CCNA maybe 1? I don't remember, 1 or 2, probably 1. Configuring your VLANs, VLAN number, VLAN name, or name and whatever you want it to be, so on and so forth. Won't dwell on that, but you're doing that on the server, of course. You're configuring your VLANs on the server, not on the clients. If you want to verify them, just do your show VLAN brief. That'll bring up the VLANs that are created, 10, 20, 30, the ones we created. If you want to see your VTP status, you've got your show VTP status command, and it shows you the revision number, which is pretty important, number of existing VLANs, so on and so forth. Domain name's up there, version number. So that can be a pretty handy command. Might be something you need on the CCNA test. I can't tell you because I have not taken it, but I would figure when I took the CCNA, they had a lot. In fact, every one of my lab questions was about troubleshooting through show commands. So I didn't even have to program anything in the CCNA. All I had to do was use show commands to figure out what was wrong. So it's a good thing to know your show commands. And the last step, make sure that your VTP clients have received the new VLAN information. If you do a show VLAN brief on the clients, of course you shouldn't have to configure the VLANs manually on them. It should just automatically happen, and you will see that your VLANs are there, hopefully, if nothing went wrong. Show VTP status on the client. If you attempt to configure a VLAN on a client, this is what you're going to get. If I go to VLAN 99, VTP VLAN configuration not allowed when device is in client mode. So those were our VTP configuration steps. This extended VLAN section is again somewhat of a review from CCNA 1. That's how you create them. You can see the range is 1006 through 4094. Not learned by VTP, does not learn extended range VLANs. You basically will create them by going VLAN and then whatever number you want to configure. Then give it a name and end. And that's about it. If If you want to assign a VLAN to a port, this is, again, CCNA 2, I think this one is. So you got your switch port, go to your interface, of course, then go switch port mode access, switch port access, VLAN, blah, whatever VLAN you want to assign to that switch port. If you want in trunk mode, you could assign a few different VLANs to that port, but this example is only doing access. VLANs can be validated using show commands. To configure extended VLANs on a 2960 switch, you must be in transparent mode. Again, those extended range VLANs are not transmitted by VTP. So if you're in transparent mode, then you're really not sharing any information. That's why extended VLANs can be used. So dynamic trunking protocol, I'm pretty sure is covered in CCNA 2 as well, but we have a review of it here. It's basically how you'd auto-negotiate a trunk. So we know we can set a switch port into access or trunk mode manually. Switch port mode access or switch port mode trunk. Okay. You also have switch port mode dynamic auto and dynamic desirable. All right. So basically, to form a trunk, you either need to have two trunks or dynamic desirable and a trunk. Well, basically, you need to have either dynamic desirable or trunk in one of the fields to form a trunk. Okay, auto, if you have two autos, you get access here. If you have an auto and an access, of course, you get access. But if you have an auto and a desirable, you get a trunk. So desirable means you want to form a trunk unless told otherwise, basically. That's what desirable kind of is doing there. Because as you can see, dynamic desirable is going to give you a trunk for everything except access. Okay, so that's what dynamic desirable wants. It wants to form a trunk, and that is the I'm sorry, that is not the default. The default is dynamic auto. So yeah, dynamic desirable will try to form a trunk. Dynamic auto is going to kind of just listen to what the other port wants to do. If they're both in auto, we get access. If it's auto, dynamic auto and access, you get access. Other two are trunks. You can just read the table there. All right. Switch port non-negotiate would be if you're trying to form a trunk with a non-Cisco device. You could go switch port mode trunk, switch port non-negotiate. That would prevent dynamic trunking protocol frames from being sent. That way, you can form a trunk with a device that is not a Cisco device. All right. Again, this is a review. Just look at the table. For what will be formed, sorry about that, for what will be formed based on your different modes that you can activate it. All right. And we move along to troubleshooting multi-VLAN issues. So some basic troubleshooting inter-VLAN connection issues. You got to delete a VLAN, just say no VLAN, and then whatever the number is, no VLAN 10, no VLAN 20. If you have interface or switch ports involved in that VLAN, you probably want to get them out of that VLAN before you delete it. Otherwise, it can cause you more work than you want to do. Take your switch ports out of that VLAN before you delete a VLAN. If a switch port is not configured for the correct VLAN, devices configured on that VLAN cannot connect to the router. Well, because you can't take that VLAN's traffic over that switch port. So you got to make sure your switch port's in the correct VLAN. You could see that through a show VLAN brief. Or you could use this command down here, show interfaces, in whichever interface you want switch port. That can do it as well. There's a couple of different show commands that will give you the information that you need to make sure that your ports are in the correct VLAN. Some other issues when enabling VLAN routing, I guess physical port issues could be something that happens when you're configuring a router on a stick and you're configuring sub interfaces. The .10, .20 for to carry your VLAN's traffic on. Common mistake is that you do a sub interface .10, for instance, for VLAN 10, and you think that that number is significant when really the significant number when you're configuring that is the encapsulation .1q number that goes with it. So even if you have a .10 for the subinterface number, if the VLAN ID with the encapsulation .1q is wrong like it is here at 100, then you're going to have an issue. So you're going to have to go in, fix that number, and things will be up and running again. You can use the show interfaces command to see that error. You can use the show running config to see that error. So yeah, that's the important part. The important part is the encapsulation .1q number that goes with it when you're typing in that command. Again, that's something router on a stick, something we went over in CCNA 2, or you should have gone over in CCNA 2. So if you want to look up that command, you can. You can. Let's see. Where are we going? There. Other issue you might have is an IP addressing issue. If the VLAN's in a certain subnet, you need to make sure that your sub interface that you connect to on the router is in the same subnet. So for instance, our issue that we have here, which is correct on the right, incorrect on the left, is you got a subnet of 10.0 basically here, /24, that is on this left side of the topology. And you can see the IP address of the PC down here is correct. It's in that 10.0 range. But you've got your sub interface on your router up here, or even just your interface. It doesn't look like it's a sub interface. Normal interface is in the 100.1 range. So that's creating a conflict. You're not going to be able to get off the network because it's not, that sub interface is not in the same range. If you tried to set up that as your default gateway on your PC, it would tell you that the default gateway is not in the same subnet. You wouldn't even be able to set that up. So you'd have to change this to a 10.1 rather than a 100.1 to correct that IP addressing issue. You can see everything is fine here. Everything's in the 30/24 network. Okay. Again, you can use show running config, show IP interfaces for that. So some more issues that we have, incompatible VTP versions. You might have a switch that doesn't support VTP version 2, for instance, and that is causing the information to be exchanged incorrectly, or there's that switch not to be able to participate in the sharing of information. So make sure all your switches are compatible with the VTP version you're running. VTP password issues, you need to make sure those passwords are set up correctly. Also, the domain name needs to be set correctly for all switches you want to participate in VTP. If all your switches are in client mode, nobody is sharing information or originating information, so no VLANs will be created. You won't be able to configure VLANs on any of them either because they're on client mode. Incorrect configuration revision number. We talked about that earlier. If that is the case, then you can have, well, if you have a higher revision number on a switch that has a bad VLAN database, maybe from another network, it's going to mess up all your other switches because by default, in general, your switches are going to take the VLAN database with the highest revision number no matter what. So you need to make sure that you don't introduce a switch into a network with a higher revision number that messes things up. DTP issues, if you have a mismatch, maybe you have a port in access mode and a port in trunk mode, and they're trying to negotiate with each other. That's going to cause a mismatch and nothing is going to be formed. Okay. Make sure your allowed VLANs on trunks are correct. Make sure your native VLANs match. If they don't, then you're going to have connectivity issues there. All right. A little breakdown of that over here. So you can go ahead and read that. And we are going to finish with layer 3 switching. So layer 3 switching is a faster way for inter-VLAN routing. It's much faster than using routers. Layer 3 switches can process millions of packets per second, and while your routers are only going to be able to do about 100,000 or so packets per second, so it's significantly faster than routing or using routers for inter-VLAN routing. You don't need to use sub-interfaces. What you do is use something called a switch virtual interface. The layer 3 switch can also act as a router when you're in like a point-to-point situation or trying to connect to some type of security device. So, only downside is they're really expensive. So, your modern internet enterprise networks will use them for speed and efficiency. So let me go back here. All right, so inter-VLAN routing. Routing can be transferred to the core and distribution layers. SVI can be created for VLANs that exist on a switch. SVIs are created for the first time in VLAN configuration mode, or for the first time. SVI is created for the first time the VLAN and first phase configuration node is entered for a particular VLAN SVI. Okay. Basically, all you're doing is creating a VLAN and assigning an IP address. That's what's happening to create a switch virtual interface. So you'll go onto your layer 3 switch, interface VLAN 10, for instance, IP address 10.1.10.1, and that virtual interface will be created. Okay, you're not creating a physical interface, it's just a virtual interface that's being created in there. You'd also create one for VLAN 20, considering that this network's on VLAN 20, give it an IP address, and you're pretty much good to go. You don't need to use any sub-interfaces or anything like that. Your VLAN 10 is going to be able to communicate with VLAN 20 through that switch virtual interface that you've created. Okay, you're just attaching it to whatever switch port on that layer 3 switch, and by having those VLANs configured internally with the correct IP addressing information, those virtual interfaces I should say, then your networks are going to communicate with each other and a lot faster than you would through router on a stick. Okay, so again, all you need to do, interface, VLAN, whatever, give an IP address, and you've got your switch virtual interface up. All right. Down here, if you're going to be using routed ports, basically you can turn any port on a layer 3 switch into a routed port by using this no switch port command when you're in that interface. Again, those routed ports on a switch are going to be used mostly for point-to-point or security devices. So a couple of the bullet points here. Routed port is a physical port that acts similar to a router interface, not associated with a particular VLAN. You cannot use sub-interfaces used for point-to-point links. And you use the no switch port command in order to do that. All right. Almost at the end, last slide. Check the following configurations for accuracy. VLANs must be defined across all the switches. VLANs must be enabled on the trunk ports. Ports must be in the right VLANs. Okay, so that's some troubleshooting. SVIs must have the correct IP address or subnet mask. SVIs must be up, no shutdown. Each SVI must match the VLAN number. Okay, so VLAN number's got to match, subnet's got to match. That's basically it for your switch virtual interfaces. Routing must be enabled. Each interface or network should be added to the routing protocol, or static routes entered when appropriate. And of course, host must have the correct IP address or subnet mask. Correct default gateway associated with the SVI or routed port on your layer 3 switch. So that's about it for troubleshooting. And that's going to be about it for the chapter. Bulk of it being that DTP and VTP. When you have labs, like I said, I've just taken this class. I'm not teaching it yet. I haven't taken my CCNA yet. I will soon. But most of your labs are going to be on that DTP and VTP configuration in this chapter. So that's going to be it for chapter 2. I plan on getting chapter 3 done sometime in the next week. I just really have to discipline myself to stay on task with this. So that's it for this video. Hopefully we'll get chapter 3 in the week of the 29th.